Yes, thanks a lot. So I will continue in English, and so if you have problems with languages, then it's the natural step that you will learn work with language technology, and that happened to me. So I work with language technology because my problem is Finnish. So I work quite a lot with translation, but I will not talk about this today. Before I'm going into some kind of future AI and arguing about language technology and how it should develop in the future, I will first make a connection between artificial intelligence research and language technology and why this is important to connect. So basically, because I don't know what your background is, I will just give you a little bit of a brief overview of what I think is language technology and also the connection to artificial intelligence research. So in my view, very, very high level, language technology is basically about building computational models, or building technology for handling languages. So we try to make languages to be handled by some kind of computational model that reflects a certain task that we humans do if we process language. So we can understand language that comes in like a language signal, and we can find out what is the meaning behind that kind of language input that we see. And on the other hand, we also can generate language that reflects meaning that we want to communicate to others. So we have those two parts that basically make up language technology and what it's all about. So trying to understand languages and trying to generate languages and having a way of finding out what the underlying meaning, so the latent meaning behind language output and input is in the picture. So giving you just a bit of a background of what the current state of the art or the current way of language technology is. So typically this is data-driven. So we work with lots of language data. So there's plenty of language data that we can scrape from the web, for example, or collect from newspapers, from other kinds of sources. And many of you have probably heard about those models that nowadays are so popular. So they come with fancy names like BERT, XLM, GPT-3, or T5. And those models, they basically read all the data, try to find templates and patterns, and squeeze it into a neural model, so this kind of neural network model that is behind those technologies, compress the information into some accessible form for the computational service that we're trying to build. So also trying to just give you still the current state of the art is that we have those models and they are basically done in different steps. So we have generic pre-training, which means that we have this kind of step of learning a big model from generic data, any kind of data that we can get our hands on. And we do generic pre-training to get a kind of source knowledge model from that knowledge source that we have. And after doing this kind of pre-training, we have a knowledge source that we can use for doing task-specific fine-tuning. So trying to model those or turn those models into very task-specific systems that can perform very exciting things that we find very exciting. Another thing that you can also do besides of fine-tuning, you can actually ask that model questions. This so-called prompting, so you can prompt it with certain input, and then the model will react with the output that it generates as a response. So surprisingly, this looks very simple actually, how to train those. So if you're not familiar with that, the kind of pre-training is very simplistic. The only thing you do is you try to predict words in context. So the typical objective for learning those models is that you take all your bunch of text, all your data that you have, you mask it in some positions. So for example, you leave out some words, and then you try to learn to predict those empty spaces. Masking is a very common trick that you do for making the model to pick up all kinds of information from the text by predicting what is missing, what kind of information is missing. And surprisingly, this leads to a very kind of complex and very knowledgeable model. So with this little simple trick, and if you scale it up to lots of data, this really finds a lot of kind of hidden patterns and hidden conceptual information that you would not expect from this simple task here. So this is all what it does, and then after that you apply, as I said, kind of task-specific fine-tuning. So you have a specific task that you would like to explore, like answering questions or translating language from one language to another. Then you can do this kind of fine-tuning by some small amount of training data that you have, and then you fine-tune that generic model that is only trained on some masked input into something that can do advanced things like generating or answering questions, free-form questions that you pose to the system. So this is, of course, very fascinating, and this is kind of the big thing that people are discussing. How does that really work? How does the model really pick up all that information, and how can it use it? And also prompting is the similar way that you can be surprised how much this model can react to just given input in text form. So the connection to AI is, I think, quite obvious. So as we now see that there's really surprising knowledge that you can get out of those models. So where does that really come from? How does the model really work that you can use, that you can do things that typically humans refer to very intelligent behavior, like answering really complex questions or translating, for example, text. So what is the secret behind all of that? How does that really work? And why are we so impressed by these very simplistic language models that really just learn to predict missing words in context? And the answer is certainly just that language is just our superpower, the human superpower. So language is really the decisive thing here. Language is the thing that we connect with almost all activities that we call intelligent behavior. We use language in things that are related to analyzing problems, reasoning, interpreting. We debate with language, we discuss, we argue, we study, teaching. Everything is really related to language use. So without language, we cannot have the capabilities of human intelligence, I would say. And this is, of course, the explanation why those models are so powerful, because they basically include all the knowledge that we squeeze into that text. All the information that we give to the model is basically there, explained in language, in the same way as we teach things in schools or teach things at the university. So it's not really actually that surprising that knowledge can come out. It's probably more surprising that we now found a way that a system can dig it out from this kind of vast amount of unstructured information that we find very unstructured. But humans do the same, so we can also dig out that information out of language. So language is the intelligence here. So we have the information in the data. The model itself is not very intelligent. It does exactly what it's supposed to do. It predicts words, predicts text. It can generate things. So now coming to the future, and future things, I think, should go much beyond this, of course. So now we have a tool that already surprises us very, very much, as we have language that can support us to, for example, finding answers. But as we look at human intelligence, of course, there's a lot more to just reflecting what you can see written in a bunch of text. And there's all the social aspects of communication and the interaction between humans. And here, I think, is also the situation where the future of language technology and also, in general, AI research will go to. So some more kind of social aspects of intelligence that need to be modeled also for AI systems. And to address those things, we built this kind of consortium where we made a proposal that would focus on especially those kind of aspects. So building socially aware multimodal AI is the big goal of that consortium that we try to build up as a project and a research network between researchers that have different aspects of communication and interaction between humans, but also between humans and machines. So giving a bit more background, here's our vision, and also maybe the motivation why we would like to work on that. So if you now look at the current state of the art in AI, this is very much connected to the physical world, so signals that we can observe, signals that sensors can take, and then trying to make abstractions on top of those. So it's a very static kind of thing, but it has impressive capabilities, as we have seen. So we can handle language quite a lot. We can get a conceptual knowledge, for example. But then, as in this picture here, there's a huge gap between what we call embodied communication between humans. So the human collaborative intelligence that we build up by interacting with each other is something that a system cannot do. There's no knowledge for the social situation in a system. It's kind of pretending to know about things, but there's no world knowledge. There's no connection between the items, the abstract concepts, and the real situation that you try to communicate with with a human or with another machine. So this kind of semantic gap there in the middle is something that really needs to be addressed to get to the next level of intelligence, also in the artificial setup. So looking at the roadmap for building this kind of AI, I have here a few points that I think we need to take. So instead of having just this kind of pre-trained large knowledge base, which is a language model, we need to have those connections between different modalities. So AI needs to really learn what I call here grounded world knowledge, meaning that AI systems need to understand what they express. So make the connections between the word apple and an apple, how it looks like. Maybe also how it tastes, how it smells. Why not? So there should be some kind of interlinked information that we call world knowledge. We know about our surroundings, our context. So this is the next step, to connect all these kind of different modalities and make the connections to language and expressions as well. So here naturally, and I should point that out, multimodality plays a big role. As we humans, we use all these different modalities like audio, video, naturally, and combine information from all of those different contextual signals that we see. All these dependencies need to be integrated. And we also need to learn about causality. So how does things become affected in a temporal dependency chain? And after that kind of building world knowledge, I think the next step would be then to use the world knowledge that you have built up and the ability of expressing things to really interacting with humans, or maybe also between machines, but also interacting in a socially competent way. This is not just for nothing that people have built up these kind of social roles and social context sensitivity. This is for actually building up our intelligence, that we can make use of kind of subjectivity in our expressions. We can make interpretation of things that are not clearly defined, but instead we can express very complex things, because language, for example, does this kind of compression and gives room for interpretation. And if we don't have kind of social context or social communication, this kind of meaning negotiation that you need to do to really understand what you're talking about does not work. So AI needs to learn also these kind of interaction possibilities. And finally, I think the next step in the future would be to really develop a system or AI systems that can use all that capability of interacting socially in different situations, interpreting things and making conclusions to really drive to be an eager learner system. So using language to be communicative with others, training itself, seeking for new goals and really asking for more information to learn by its own kind of curiosity and its own reward. So for me, language is always included in all those steps, even if you have multimodality and other kinds of signals, very important. But the glue is really language here. And I think I try to make at least the point here that without language, I think you would not get very far. And I hope you can get convinced by this kind of presentation here. But I think this is what I wanted to say. So with that, I just conclude with socially aware AI is required in future developments, and it will definitely include interactive multimodal language technology. Thank you.